have another example for the confidence interval for a population proportion. A chef at an Italian restaurant changes his lasagna recipe one evening. The restaurant manager polls the customers who ordered the lasagna to find out if they prefer the new recipe or the old recipe. We found that 65% of 20 customers report that they prefer the new recipe. Find a 95% confidence interval for the proportion of customers who prefer the new recipe. All right, so again, we're going to write down some key information. We have a sample proportion of 65%. So I'm going to say p hat equals 0.65. We have a sample size of 20 customers. We want a 95% confidence interval. And I could look back at that table and see if I want a 95% confidence interval. I'm going to use a z-score of 1.96. So the first question is just, what is the standard error? So the way we can estimate the standard error is we want p hat times 1 minus p hat over n. So in this case, that is 0.65 is p hat. 1 minus 0.65 is 0.35, and we're going to divide that by the total sample size, which is 20. And if you work through all of that, you'll get 0.107. What is the margin of error? So remember, the margin of error is the estimate of the standard error times the z-score. So it's just going to be our z-score 1.96 times the estimate of the standard error, 0.107. And so that's about 0.21. Can the manager conclude that the majority of customers prefer the new the new recipe? So to get my confidence interval, I'm going to take my point estimate, 0.65. I'm going to add and subtract the margin of error, 0.21. And I'm going to see that my confidence interval is 0.44 to 0.86. So what I have now is my range of believable values for the population proportion. So can we conclude that the majority of customers prefer the new recipe? Well, the problem is that the majority means 50% or above. So part of our interval is above 50%, but not all of the interval. So it's kind of inconclusive. So I really can't definitively draw that conclusion. So I would say no. The confidence interval contains 0.50. And you could elaborate and say and above 0.50. But 0.50 was kind of our key number. If it was completely below 50%, then we would know, okay, it's not the majority. If it was completely above 50%, then we would say, yeah, it's appears that it is the majority who prefer the new recipe. But since it contains 0.50, then we're in a gray area, and it's not conclusive either way. So 0.50 is kind of the key number there. Are there any concerns regarding using this confidence interval? So in this question, I'm looking to see if those two properties that we talked about previously are met. So I want to know, do I have a random sample? And I'm not told anything about how the sample is collected. So I'm going to say there are concerns not a random sample. And, you know, for this class, I mean, if you are trying to figure out, is it a random sample or not, the only way you're going to know is by reading the question. Does it tell you it's a random sample? It didn't say that here, so we can't assume it's a random sample. Also, we have an issue with the sample size. Sample size is small, right? Remember, we need n times p and at least n times p and hat and n times 1 minus p hat are both at least 15. But here I have n times p hat equals 20 times 0.65, which is 12. That is less than 15. All right, so this assumption does not check out. So that's kind of an issue there. So we can still construct the confidence interval, but we are just going to be cautious with interpreting it and putting weight on the interpretation since these two conditions were not met.